Okay, this video is about verifying identity. So, first let me just address why we're even doing this. It seems like, why are we even having to learn this? Okay, the main reason we are learning how to use identities and what identities are is because sometimes it is much easier and convenient to work with identities in a certain form than the other form. Okay, so for instance, sometimes, like, here's an identity: x times 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 x. Let's see. Is equal to x to the 8th. Okay, this is a very basic example, but this is an identity. 8x is multiplied together is equal to x to the 8th. Would it be more convenient if you had to write this over and over and over again to write it out this many times, or just to write x to the 8th power? That would be way easier. Okay, that's a very basic example, but for those of you who are continuing on your math journey into, and I know some of you guys get off the track after this, and congratulations, but some of you guys go on to Calc 1, or Calc 2, or Calc 3, and you continue on. Especially when you get into calculus, Calc 2 in particular, you need to be able to rewrite trig identities in different ways in order to integrate them or to take their derivative, which is something you learn about in trig. So that is one of the main applications that you'll use in math. But you can see, like, we even use this all the time, right? If I change these to plus signs, right? What is an identity that we could use here? Well, 1, 2, 3, 4, 5, 6, 7, 8 x's. We could write it x plus 8 times, or we could say this is really 8x. That is another example. So that's kind of why we're doing this. To verify an identity. So once you say, once I say, hey, this is the truth, it's been proven, I believe this, I can use this, then I can use 8x every time. But up until that point, I have to use this until I'm sure that it's true. So how do we say, yes, this is truth, we know this is truth, you know? You have to verify it. So what does verification mean? It's in the little box that I put on your sheet. It says, to verify an identity, start with the expression on one side of the equation, and through a sequence of valid steps. That's really important. You can't make up false math. That's a big no-no. So a sequence of valid steps involving the use of known identities or algebraic manipulation, convert the expression into the expression on the other side. So this is just a for example. I made this up. For example, what if we have to show that 2/3 times 9x plus 1 minus 8/12 plus 4x. We have to verify that this side equals to this side. Now, we're not using trig, but this is just an example of what does verification mean. Well, if you look below it, let's look at some of the recommendations. There's like a box that says, hey, here's some good ideas. It's not foolproof. I mean, sometimes you have to go think outside the box and do some weird things, but usually this is a really good guidelines to follow. So it says suggestions. Step 1, start with the more complicated side and try to make it look like the simpler side. That's what number 1 says. Use basic or other known identities. Use algebra for number 3. Sometimes you have to factor. Sometimes you have to add fractions together, like I did in the first video. Sometimes you have to split up fractions. Number 4, if other steps fail. Sometimes you go down a road and it's a bad path and you got to start over. That happens. That's a normal part of the process sometimes. If other steps fail, try expressing each function in terms of sine and cosine. Go back to the basics and then perform a bunch of algebraic steps. So if you can't get there through more sophisticated methods, just go back to the basics. At each step, keep the other side of the identity in mind. This often reveals what you should do in order to get there. So that's what I mean when you're verifying an identity, you can kind of see the end game. You can say, oh, that's what I'm trying to get to. I have that in mind. You kind of keep that in mind. So let's give this a shot. This, if I have to verify this identity, say, show that this is an identity, I see that I want it to end up looking like, either I have to take 2x and make it look like this, or I have to take this and make it look like 2x. So I'm only going to work with one side of the equation. And I'm going to choose the more complicated side because there's more things I can see to do. And then I'm going to try to make it look like that. So what I can see to do is maybe distribute the 2/3 to each of these. And then also, was there anything in front of that? No, there wasn't. There's a -1 right here. I can distribute the -1 to both of those. So let's see what that looks like. 2/3 times 9x. I can write the 9x over 1 if I want. Plus 2/3 times 1, which I'm going to write it like that. Minus 1 times 8/12 is minus 8 over 12. Minus 1 times 4x is minus 4x. And let's see what we can get this to equal to. All right. Right here, I have 2 over 3 times 9x over 1. 3 can go into 9 3 times. So really I have 2 times 3 times x over 1, or just 6 times x. Plus 2 times 1 is 2. 3 times 1 is 3. Minus 8 over 12 minus 4x. Okay, let's see here. Look at this 8 over 12. Is it possible to simplify that? These have a common factor of 4. Can I do that? I'm going to divide 8 by 4, and that gives me a 2. And 12 divided by 4 gives me a 3. So really 8 over 12 is 2/3. So what I have here is a 6x plus a 2/3 minus a 2/3 minus 4x. This plus this is 0, so I have 6x minus 4x, and so I get 2x. Oh, that's what I wanted it to be, equals 2x. So notice I worked with one side of the equation until I made this side look like that side. That's what we're going to be doing, only we're going to be doing it with trig. So here we go. Let's try number 1. And see how it goes. Number 1 says this. We've got the cosecant of theta times the cosine of theta plus the sine of theta. And we want to show that this equals to the cotangent of theta plus 1. Now, let me also say this. There are many, many correct ways to go down this path. So when you're doing your homework, or what if you're trying this on your own, and you do it a different way, but you end up at the same place, that will happen too. So there's not just one way to do this. It's kind of however you see it, as long as we're not breaking math rules and we're not making up things that are not true, we're okay. All right, so let's see. What would I do here? Which side would I start with? I'm going to choose to start with this side. It looks like I can see something new. I'm going to distribute this. That's what I see. So let me distribute the cosecant to each of these terms. So that becomes cosecant of theta times the cosine of theta plus cosecant of theta times the sine of theta. All right. Then I think I'm going to rewrite cosecant into its sine cosine form. So this is going to be 1 over the sine times the cosine. And if I want to write that over 1, it's fine. This is 1 over the sine times the sine. And I'll put him over 1. All right, what do I have here? I have 1 times cosine over sine times 1 plus 1 times sine over sine times 1. Oh, you know what? Let's just say this goes into this 1. So 1 times 1 over 1 times 1 is a 1. All right. Cosine over sine is really cotangent of theta plus 1. Oh, then I made this look like this. Now, there will be times when I ask you to tell me what steps you used. So let's practice that with this one. What did I do here? I just distributed. So this is called I distributed. Distribute. Then what did I do here? Oh, I wrote in terms of sine, wrote as sines and cosines. But there's an identity this is called. This is the reciprocal identity that I use here. Or I could say let me write that, it's better. I use the reciprocal identity. So if you go back and look at the sheet I gave you for 4.1, you'll see the names there. Reciprocal identity identity. Okay. And then I just multiply fractions. Okay, multiply fractions. And then I took this and I wrote it like this, which is a quotient identity. Quotient identity. Now, I won't make you do this all the time, but there will be times, maybe on the test, where I'm like, tell me exactly which steps made it valid for you to use this. Okay, let's do number 2 and see how this goes. They give us that they give us the tangent of u is equal to, oh no, it's times some other stuff, isn't it? All right, tangent of u over the sine of u, the tangent, number 2, of u over the sine of u minus the cotangent of u over the cosine of u is equal to the secant of u minus the cosecant of u. All right, so I'm going to start with this side. Let me see what I can do here. Tangent, I'm going to rewrite tangent into sine and cosine. So this is going to be the sine over the cosine over the sine. I just rewrote the tangent minus cotangent. I'm going to rewrite him in cosines and sines. Cosine over the sine over the cosine. All right, so I'm still on the left side. Now, what can I do with that? Oh, you know what? This is over 1, right? This is a complex fraction. You know what I'm going to do? I'm going to change flip. I'm going to keep the numerator, sine of u over cosine of u. I'm going to change the operation from division to multiplication. Then I'm going to flip or multiply it times the reciprocal of the denominator. I'm going to do the same thing here. Keep, change, flip. All right, what does that do? Oh, hey, cool. Sine goes into sine 1 time. 1 times 1 is 1. Cosine times 1 is cosine. Cosine goes into cosine. 1 times 1 is 1. Sine times 1 is sine. All right, what am I trying to make it look like? Oh, I'm trying to make it look like that. Let's use one of those identities. 1 over the cosine is really the secant. 1 over the sine is cosecant. Oh, I made it look like that. Okay, I'm going to write the steps here just so that you've seen it and know how to do this, should I ever ask for it. But I won't do this the rest of the video because time, okay? So what step did I do? What did I do here? I wrote tangent as sine over cosine. I wrote cotangent as cosine over sine. Those are quotient identities. I used the quotient identities is what let me do that. Okay, what happened here? I changed from this step to this step. This is simply division of fractions, right? A fraction divided by a fraction. I divided fractions. All right, cool. After that, I had this. Fine. I went from here to here. What did I do going from here to here? Oh, I rewrote 1 over the cosine as this and 1 over the sine. This is called reciprocal identities. Reciprocal identities. That's what allowed me to do that. Okay, the rest of these I'm just going to go through. I won't be writing all the steps. So number 3 and number 4 go like this. Okay. So these are easier to know if you got the right answer or not, because if it looks like the other side, you did. Okay, but notice I'm only working with one side at a time. That's important. Okay, number 3 goes like this. 1 over secant squared of m plus 1 over cosecant squared of m is equal to 1. 1 over secant is cosine. So 1 over secant squared is really equal to the cosine squared of m. 1 over cosecant squared of m is really 1 over sine squared of m. This is 1 1 over cosecant is sine, so 1 over cosecant squared is really sine squared of m, and this is equal to 1. Oh, you know what? I saw this somewhere called the Pythagorean identity. 1 is equal to 1. So if I was making you write down the reasons, the reason for this one would be the Pythagorean identity. All right, that's 3. Here comes 4. Goes like this. The cosine squared of x times tangent squared plus 1 has got to equal to 1. Oh, is that a typo? We're about to find out. Plus cosine squared of x. Is that 1 times cosine squared of x? I don't know. We'll find out. Let me see if I typed that in wrong. Okay, let's see what happens. Oh, this looks like something I can do something with. This looks like a Pythagorean identity to me. So let's see what that is. If we've got, we got sine squared, cosine squared is 1. We've got tangent squared plus 1 is secant squared. This is tangent squared plus 1. This is really secant squared. That's what that's equal to. Oh, this is supposed to be 1. That's what that's supposed to be. I had a typo on my page. Okay, this is supposed to be a 1. So let's see. Tangent squared x plus 1 is really equal to secant squared. So this is cosine squared of x times secant squared of x. Okay, this is cosine squared of x over 1 times 1 over cosine squared of x. And so these can divide into each other, and we just get 1 times 1 is 1. And so then that one's verified. So that tells me I got a little typo on my page. I gotta fix it. All right, number 4 goes like this. If we've got the cosine squared of x times the tangent squared of x plus 1. Wait, that's what I just did. Oh, we're through with number 4. We're going to take a break because obviously I need one, so.